This is Andromeda, our closest galactic neighbor. So many stars. It's like sand in the sea. But just think, every single one of these dots is a giant star, individually visible to us 2.5 million light years away. Each star likely has its own planets, comets, asteroids, its own story. The Hubble Space Telescope has just created the most in-depth and complete image we have ever seen of the Andromeda Galaxy. And we're seeing it in a new light. A light so brilliant and bright that by the time we get to the galactic nucleus, the stars are so densely packed together that they appear like a brilliant, solid, golden glow. This is no gentle spiral in the night sky. Andromeda is home to violence, a place whose presence has cataclysmic consequences for those nearby, including us. I'm Alex McColgan and you're watching Astrum. Join me today as we take a trip next door to the Andromeda Galaxy and explore arguably the most impressive image of another galaxy ever taken, including 200 million of its stars. We'll show how Hubble's groundbreaking new portrait is being used to piece together Andromeda's turbulent past and predict what violence might be on the cards in its future. We've been observing Andromeda for more than 1,000 years. It was first spotted in 964 AD by Persian astronomer Abdul Rehman, who described what he saw as a nebulous smear. We didn't really get a better look than that until nearly 700 years later, when, on the 15th of December 1612, Simon Marius became the first ever person to observe the Andromeda Galaxy through a telescope. Slowly but surely, more details of this seemingly fuzzy nebula emerged. Charles Messier officially classified it M31 in 1764, but one of the most important breakthroughs came 100 years later. The third Earl of Rosse, William Parsons, was a keen yet eccentric amateur astronomer. He had the massive 72-inch Leviathan of Parsonstown telescope built in the garden of his Birr Castle in Ireland. It remained the largest telescope in the world for some 70 years. Parsons used this beast of a scope to spot the spiral structure of a nebula named M51, or, as it's known to most of us, the Whirlpool Galaxy. It was the first time a spiral structure had ever been seen in a nebula, and the discovery sparked a flurry of interest from astronomers of the time. As they turned their attention to other nebulae, it resulted in the first ever photograph of the Andromeda Galaxy, taken by amateur British astronomer Isaac Roberts in 1888. And that photo, as you can see, shows a clear spiral structure. Even with this photographic evidence, scientists weren't sure what Andromeda was, but they classified it, alongside thousands of other spiral nebulae, that all had something else in common. They didn't move like the rest of the stars in the night sky do. This realization inspired one of the major debates among astronomers in the late 19th century. Were spiral nebulae part of our own Milky Way galaxy? Or could there possibly be other island universes beyond? In 1925, Edwin Hubble resolved the issue. Hubble identified two Cepheid variables in the Andromeda Nebula. Known as standard candles, these variable stars can be used to measure galactic distances thanks to the correlation between their period and luminosity. Hubble calculated that these Cepheids were about 1 million light years away, far too far for them to lie within the bounds of the Milky Way, which, at the time, was estimated to be no wider than 300,000 light years across. With that single realization, Hubble proved Andromeda was a galaxy in its own right, and the universe suddenly became a lot bigger than anyone had previously thought. It must have been annoying to astronomers who thought Andromeda was just a nebula, but a rug pull like this could have been much more painful. Our world is increasingly filled with things that aren't what they seem. Nigerian princes want to deposit their millions of dollars in your bank account, innocent downloads that are secretly trying to infect your computer with malware, even fake shopping websites that take your money and then vanish into the night. Thankfully, there is a tool that can protect you from 3/4 of these rug pulls. The sponsor of today's video, NordVPN. Whether it's phishing attempts, malware, or fake online shops, NordVPN's Threat Protection Pro goes further than any other VPN in keeping you safe from criminals. It's recognized by leading cybersecurity lab AV as having one of the best detection rates for fake shops, being highly effective at spotting phishing scams, and having some of the best anti-malware compared to similar VPNs. It doesn't warn you Andromeda is a galaxy, but 3 out of 4 isn't bad. So cut through the scams, go scan my QR code or visit the link nordvpn.com/astrum in the description for a special 4 months extra on your NordVPN subscription. It's risk-free with Nord's 30-day money-back guarantee. Since Hubble's discovery that the universe extends beyond the Milky Way, we've discovered countless galaxies. But we still share a special relationship with the one that opened our eyes to the vastness of space, our cosmological next-door neighbor. Andromeda has arguably taught us more about how galaxies work than even our own. You see, it's tricky to study galactic structure in the Milky Way because we're inside it. There's quite a lot of stuff to get in the way. Interstellar dust can scatter light so that objects look redder than they should. It's tricky to measure accurate distances, and sometimes details are blocked by noise in the foreground. Andromeda, or M31, however, doesn't have many of these issues. At around 2.5 million light years away, it's a place where we can study galaxy formation and evolution relatively unimpeded. But to make the best use of this laboratory, we need clear images. Experts and amateurs, ground-based and space telescopes have all taken a look at Andromeda from a number of different angles, resolutions, and wavelengths. But on the 16th of January 2025, the Hubble Space Telescope released an image that put all our previous efforts to shame. After 10 painstaking years of observing Andromeda, it has created the largest photomosaic ever assembled. Taken over 1,000 Hubble orbits, it encompasses more than 600 snapshots and 2.5 billion pixels. The result is the most in-depth and complete view of Andromeda we have ever seen. So, without further ado, let's take a look. This image shows Andromeda nearly edge-on, tilted 77 degrees relative to our view from Earth. In it, you can see the northern region to the right and the southern region to the left. Astronomers predict that Andromeda could be home to as many as 1 trillion stars, but most are too dim to be detected even by a powerful telescope like Hubble. Nevertheless, it was able to resolve a whopping 200 million stars, making it the most detailed image ever taken of any galaxy anywhere in the universe. With such a stunning census of our closest neighbor, scientists have been able to reveal more about its history, how it compares to our own cosmic home, and how it may evolve in the future. We know Andromeda is a spiral galaxy measuring around 150,000 light years across, with arms that extend out from its nucleus across the sky. Despite this classification, many of its features are pretty unusual, and thanks to this new image, we are starting to understand why. Created in 2015 with the conclusion of the FAT program, or Panchromatic Hubble Andromeda Treasury, this image is highly zoomable. And so it should be. Hubble spent more than 3 years photographing a third of Andromeda's star-forming disk. These images were taken across 6 spectral bands, ranging from near ultraviolet to near infrared. If you take a look at the outer region, you can see an elliptical ring of star formation found roughly 10 kiloparsecs from Andromeda's nucleus. These newborn stars are bluer and therefore hotter than most other stars in this region. They are also metal-rich, meaning they contain elements heavier than helium or hydrogen. The more you zoom in, the more of these individual stars appear. There are so many. The Hubble team say they look like grains of sand on a beach. The resolution is truly that good. This ring of star formation puzzled astronomers, and it wasn't the only thing. Using images taken by the infrared array camera on the Spitzer Space Telescope in 2006, researchers found a second inner dust ring, situated about half a kiloparsec from Andromeda's center. This one was hiding in plain sight. Initially, scientists had assumed it was a mini spiral related to dense regions of overlapping stellar orbits. 2 rings meant that what scientists were seeing couldn't just be an anomaly. But where did they come from? These rings were about to unlock Andromeda's past. For decades, scientists had looked at the galaxy and found little evidence to suggest a violent history, but these rings showed a different story. As astronomer and author of the 2006 study, David Block, put it, "These dust rings are like ripples in a pond." And where do ripples come from? A point of impact. That's right, scientists concluded the rings were the remnants of a collision between Andromeda and one of its companion galaxies around 210 million years ago. Just like a stone being dropped into a pond, the impact between Andromeda and this other galaxy produced shockwaves of dust that radiated through the disk, leaving behind 2 ghostly trails we can still observe today. Block and his colleagues blame dwarf galaxy Messier 32 for this impact. Today, it appears as a bright, fuzzy haze of stars, found just 5 kiloparsecs from Andromeda's center. When they ran numerical simulations to recreate the impact, the authors found that a head-on collision was able to reproduce the rings we see today. There is a conspicuous hole in the outer ring that was formed when it interlaced with Andromeda's spiral, and the simulations were even able to recreate this feature. Since that discovery in 2006, many thought that we had revealed the extent of our galactic neighbor's trauma. But thanks to Hubble, Andromeda was about to give up more of its secrets. You see, the 2025 image of Andromeda was made from the combined efforts of not only the FAT survey, but also the FAST survey. This extended the original program to photograph Andromeda's southern region and ran from 2021 to 2024. FAST added a further 90 million stars to the census and expanded its scope to cover 2/3 of the galaxy's star-forming disk. The need for this southern focus survey was born out of the realization that Andromeda's polar regions are almost nothing alike. The southern region appears to be far more disturbed than the north, and therefore carries more evidence of Andromeda's violent history. And there's plenty of battle scars to find. You can't really make it out in the Hubble image because it's too dim, but the giant southern stream is a mammoth feature of Andromeda that spans around 150 kiloparsecs from the galaxy's southern disk into the halo. You can think of it as a stream of debris from a galaxy that was stripped of its stars by Andromeda's gravity. The GSS is dissipationless, meaning the stars in it are cold and hold no significant amount of gas. Their paths are still dictated by gravitational forces, but they don't radiate heat or collide with other stars in the stream. It's like a group of marbles rolling down separate, frictionless tracks. The GSS, along with M32 and the inner halo, are 3 of the most prominent metal-rich features found in Andromeda. For some astronomers, their shared metallicity suggests they are all products of another major collision event in Andromeda's history. even larger than the one that produced the rings. But this event has a familiar antagonist. A study in 2018 sought to investigate this bigger collision and put the spotlight back on M32. Well, M32's ancestor. Cosmological simulations named Andromeda's most likely victim as an earlier version of M32, named M32P. In its heyday, this ancient, metal-rich galaxy had a mass of 25 billion suns and merged with Andromeda between 5 and 2 billion years ago. Its gas would have been vacuumed up by the greater force of Andromeda's gravity, triggering a burst of star formation which created about a fifth of the stars we see in our galactic neighbor today. And what's more, we think we know which ones they are. Andromeda contains several billion stars that are of intermediate age, and astronomers had been struggling for years to explain why. They expected Andromeda's stellar population to look more like that of our Milky Way, distinct regions of much older stars in the bulge and halo, and younger stars in the thin disk. However, if these middle-aged stars formed during the merger with M32P, then we finally have an answer for where Andromeda's second wind of star formation came from. For more proof, we just have to look at M32 in Hubble's new image. If we go with the theory, then what we are seeing is the stripped core of M32P, and that description seems to fit. M32 has a central black hole with a relatively low mass, between 1.8 and 5 million solar masses, and astronomers can use this to work out how big its central bulge might have been before it merged with Andromeda. These calculations show that M32P's central bulge was small, which explains why the galaxy did not sink completely into the center of Andromeda during the merger. Instead, the stripped core was able to survive on the outskirts of the galaxy, where it remains to this day. As I said, this is still a theory, but it appears to answer a lot of questions about Andromeda's troubled past and unites several of its most unusual features together. But things might still be more complicated than that. Andromeda has 36 different dwarf galaxies surrounding it, and any one of these galaxies may have interacted with it in the past. It's only now that we have such a high-resolution view of our neighbor, thanks Hubble, that we can start to look for signs of small-scale interactions with its satellites. Who knows what we'll find? But it's not all about the past. This spectacular image can also tell us about the future, our future. As the two biggest gravitationally bound members of the local group, Andromeda and the Milky Way are often thought to be the most likely candidates for a collision. It was estimated in 2012 that Andromeda is falling towards our home galaxy at a rate of 110 kilometers per second and will hit in about 4 billion years. Of course, this is probably not a threat that the human race will ever have to worry about, but it's fascinating to think about how these two beloved galaxies could change if a collision ever comes to light. But before you start imagining what Milkomeda would look like, it's important to highlight that this is still a debate. Thanks to the new image from Hubble, we have reason to believe that our galaxy could live to fight another day. In a paper published this year, Till Svala from the University of Helsinki and his colleagues used the Hubble data on Andromeda to refine the models of the local group. Specifically, the FAT survey measured distances to 55 Cepheids within Andromeda. These, combined with the orbit of other local group galaxies like the Large Magellanic Cloud, showed that the fate of our galaxy was much more uncertain, with only a 50% chance of a merger with Andromeda in the next 10 billion years. Predicting what will happen to our galactic neighborhood in billions of years is no mean feat, but it will be much easier now that we can see its current state so clearly. The 10-year endeavor of the FAT and FAST programs has now come to an end, but the work doesn't stop there. With enough detail to cover 75 8K ultra-high definition screens, Scientists are nowhere near done finding the secrets hidden within this image. And it's just one of a seemingly never-ending stream of clues. Hubble may have turned its attention somewhere else for now, but in June this year, more images were released from the Chandra X-ray Observatory, showing Andromeda's supermassive black hole in unprecedented detail. With each observation adding ever more detail, the story of Andromeda will become even more complete over the next few years, and so far, it's shaping up to be a good one. I can't wait to see what Hubble's scientists piece together next. But in the meantime, I hope this video has brought you closer to Andromeda. After all, we are neighbours, and we could be getting a lot closer in a few billion years. Thanks for watching. I want to give a quick shout out to a special Supermassive Black Hole tier member on Patreon, Tom Ellis. Thank you for going above and beyond to support the channel. If you've been enjoying Astrum's videos and want to help keep this channel thriving, I want to ask you to take less than a minute to check out the Astrum Patreon. It's not just ad-free videos, but it's a way to make Astrum's videos less reliant on sponsors and algorithms. The link is below. Thanks so much for considering it. I'll see you next time.